Gamma distribution. So let us study the definition of gamma distribution. A continuous random variable, capital X, is said to have a gamma distribution if its PDF, probability density function, is given by f of x equal to m raised to p divided by gamma p e raised to minus mx x raised to p minus 1 for all x greater than 0 equal to 0 elsewhere, where m greater than 0, p greater than 0 are called parameters of gamma distribution. This letter is read as gamma p, and we know that this is a probability density function. Therefore, integral minus infinity to plus infinity fx dx equal to 1. That is, totality of a probability density function is 1. Here the range is from 0 to infinity, so we can rewrite this as integral 0 to infinity. Instead of fx, we can write m raised to p divided by gamma p e raised to minus mx x raised to p minus 1 dx equal to 1. Equal to 1. Therefore, integral 0 to infinity e raised to minus mx x raised to p minus 1 dx is equal to gamma p divided by m raised to p. This is a very important result while doing some problems. If m is equal to 1, this expression becomes integral 0 to infinity e raised to minus x x raised to p minus 1 dx is equal to gamma p. Gamma p is equal to integral 0 to infinity e raised to minus x x raised to p minus 1 dx. If m equal to 1 and p equal to 1 by 2, the expression integral 0 to infinity e raised to minus x x raised to p minus 1 dx becomes integral 0 to infinity e raised to minus x x raised to 1 by 2 minus 1 dx is equal to gamma 1 by 2 divided by 1. That is, gamma 1 by 2 is equal to integral 0 to infinity e raised to minus x x raised to minus 1 by 2 dx. And this is equal to root pi by definition. Therefore, some important results. Integral 0 to infinity e raised to minus mx x raised to p minus 1 dx is equal to gamma p divided by m raised to p. Then integral 0 to infinity e raised to minus x x raised to 1 by 2 minus 1 dx is gamma 1 by 2, that is equal to root pi. And integral 0 to infinity e raised to minus x x raised to p minus 1 dx is gamma p. And one more result. For p greater than 0, we have gamma p is equal to p minus 1 factorial. Or we can write gamma p is equal to p minus 1 into p minus 2 factorial, that is p minus 1 into gamma p minus 1. Therefore, we can write p into gamma p is equal to p factorial or gamma p plus 1. So, these are some important results while going through gamma distribution. Now, let us study the moments of a gamma distribution. First, let us study what is mean. Mean is E of x is equal to integral minus infinity to plus infinity x fx dx by definition. Here the limit is from 0 to infinity, so integral 0 to infinity x, and probability density function is m raised to p divided by gamma p e raised to minus mx x raised to p minus 1 dx. We know that m raised to p and gamma p are constant, so we are taking that outside. M raised to p divided by gamma p integral 0 to infinity. Combine this x and this x together. We have e raised to minus mx x raised to 1 plus p minus 1 dx, which is equal to m raised to p divided by gamma p. From this expression we know that integral 0 to infinity e raised to minus x x raised to p minus 1 dx is gamma p divided by m raised to p. So from this one we can write this as gamma p plus 1 divided by m raised to p plus 1. Gamma p plus 1 is p into gamma p. So we can write this as m raised to p divided by gamma p into gamma p divided by m raised to p plus 1. This gamma p and gamma p get cancelled. M raised to p and m raised to p get cancelled. We have p by m. So, mean of a gamma distribution is p by m. Now let us study variance. Variance of a random variable is expectation of x square minus e of x whole square. And we know that what is e of x? It is p by m in the case of a gamma distribution with parameter m and p. So we have to find e of x square. It is integral 0 to infinity x square into m raised to p divided by gamma p e raised to minus mx x raised to p minus 1 dx. That is m raised to p divided by gamma p outside, integral 0 to infinity. Combine x square and x raised to p minus 1. E raised to minus px x raised to p plus 2 minus 1 dx. So how we can rewrite this expression? M raised to p divided by gamma p into, this is gamma p plus 2 divided by m raised to p plus 2. Then what is gamma p plus 2? We know that gamma p plus 1 is p into gamma p. Therefore, gamma p plus 2 is equal to p plus 1 into gamma p plus 1. Again we can rewrite this as p plus 1 into gamma p plus 1 as p into gamma p. So gamma p plus 2 becomes p plus 1 into p into gamma p. So this one becomes m raised to p divided by gamma p. Instead of gamma p plus 2 we can write p plus 1 into p into gamma p divided by m raised to p plus 2. This m raised to p plus 2 and m raised to p and m raised to p plus 2 get cancelled. Gamma p cancelled. So we have p into p plus 1 divided by m square as an expression of e of x square. So what is variance of x? Variance of x is equal to p into p plus 1 by m square minus. We know that e of x is p by m. So e of x square is p square by m square. P square by m square plus p by m square minus p square by m square. P square by m square get cancelled. So we will get this as p by m square. So variance of x, variance of a gamma random variable is p by m square. So standard deviation of x is root of variance of x, that is root p by m. Now let us study the moment generating function of a gamma random variable. mxt, by definition mxt we know that expectation of e raised to tx, that is integral minus infinity to plus infinity e raised to tx fx dx. Here the range is from 0 to infinity and f of x is, which is equal to integral 0 to infinity. Since the range is from 0 to infinity, e raised to tx into m raised to p divided by gamma p e raised to minus x raised to p minus 1 dx, since this is the f of x of a gamma distribution. Take m raised to p by gamma p outside being constant, integral 0 to infinity. Combine these two, e raised to tx and e raised to minus x together. We have e raised to tx minus mx x raised to p minus 1 dx. For getting a convenient format, we are going to rewrite this e function as m raised to p divided by gamma p integral 0 to infinity e raised to, take a minus sign outside, minus. When we are taking a minus, this one becomes minus tx and this one becomes plus mx x raised to p minus 1 dx. So we can take x also outside. M raised to p divided by gamma p integral 0 to infinity e raised to minus of x into minus t plus m x raised to p minus 1 dx, that is m raised to p divided by gamma p integral 0 to infinity e raised to minus t plus m, we will write as m minus t x raised to p minus 1 d. So what happened to the term within this integral sign? This one becomes gamma p divided by, instead of m we have m minus t all raised to p. Gamma p and gamma p get cancelled, so we have m by m minus t all raised to p, which is again equal to m minus t by m all raised to minus p. When we are taking the reciprocal, we can rewrite the expression like this. That is m by m minus t by m raised to minus p. That is equal to 1 minus t by m raised to minus p. Therefore, moment generating function of a gamma random variable is 1 minus t by m raised to minus p when m and p are the parameters of the distribution. So, in the case of a gamma distribution, probability density function f of x is m raised to p divided by gamma p e raised to minus mx x raised to p minus 1 for x greater than 0 and equal to 0 elsewhere. Mean is equal to p by m. And one more thing, p and m are called parameters. Variance is p by m square, and moment generating function is equal to 1 minus t by m raised to minus p. And again we know that integral 0 to infinity e raised minus mx x raised to p minus 1 dx is gamma p divided by m raised to p. Then again we know that integral 0 to infinity e raised minus x raised to 1 by 2 minus 1 dx is gamma 1 by 2, that is root pi. That is when m equal to 1 and p equal to 1 by 2. If m equal to 1, we can rewrite this expression again as integral 0 to infinity e raised to minus x raised to p minus 1 dx, which is gamma p. And we know that gamma p is p minus 1 into gamma p minus 1. Again, gamma p is equal to p minus 1 factorial. P into gamma p is gamma p plus 1. Now let us discuss this problem. Derive the moment generating function of gamma distribution and hence obtain its mean and variance. So first we have to derive the moment generating function, and from that moment generating function we have to find mean and variance. Don't find mean and variance directly, we have to find mean and variance from the moment generating function. So first we have to write all these steps of finding moment generating function, and we will reach at mxt is equal to moment generating function is equal to 1 minus t by m all raised to minus p, where m and p are called the parameters of gamma distribution. So how we can find mean from this moment generating function? We know that mean is equal to mu1 dash is d by dt of mxt at t equal to 0. That is mu 1 dash is the first order derivative of mxt with respect to t and putting t equal to 0. And for finding variance, we have to find mu 2 dash. What is mu 2 dash? Mu 2 dash is d square by dt square mxt. That is second derivative of moment generating function at t equal to 0, and variance is equal to mu 2 dash minus mu 1 dash square. These are the basic things we want to remember. For finding mean, we have to first find d by dt of mxt, that is first order derivative of mxt with respect to t. So d by dt of mxt is d by dt of, what is mxt? 1 minus t by m all raised to minus p, which is equal to minus p into 1 minus t by m raised to minus p minus 1 into derivative of 1 minus t by m, that is minus 1 by m. So this is p by m into 1 minus t by m raised to minus p plus 1. Then let us find the second order derivative. D square mxt by dt square, that is d by dt of mxt, that is d by dt of p by m into 1 minus t by m raised to minus p plus 1. Which is equal to p by m. It's a constant, take outside. Into minus p plus 1 into 1 minus t by m raised to minus p plus 1 minus 1 into derivative of 1 minus t by m is again minus 1 by m. So we have minus and minus become plus, p into p plus 1 by m into m square into 1 minus t by m raised to minus of p plus 1 minus 1. Mean, that is mu 1 dash is equal to d by dt of mxt at t equal to 0. That is p by m into 1 minus t by m raised to minus p plus 1 at t equal to 0, which is equal to p by m. That is putting t equal to 0 here. We have a 1 in this bracket, so we are getting mean as p by m. Then let us find mu 2 dash is d square mxt by dt square at t equal to 0, which is equal to p into p plus 1 by m square into 1 minus t by m raised to minus p plus 1 minus 1 at t equal to 0. Put t equal to 0 in this expression, so t by m becomes 0. So we have 1 here. So this one is p into p plus 1 by m square. So variance of x is mu 2 dash minus mu 1 dash square, that is p into p plus 1 by m square minus p square by m square, which is equal to p by m square. But after simplifying this one, we will get p by m square.